Hello, welcome to the final unboxing for the ON20 series. Are you relieved, Miss Ellie?
Oh yes.
We have
Finally,
finally,
we are done.
we have finally reached a landmark or at least a checkpoint before we start our journey, our long and winding journey into A2. So in this unboxing, we'll just go through the paper, maybe share some thoughts, do some reaction. Full disclosure, we have actually attempted the paper before this so the video does not run too long. Okay, so let's start with question 1. Miss Ellie, what is a
This
reasonable
one,
estimate of a football?
actually, when I saw football, I was thinking, you mean the American football or the round one where people kick? I was confusion for one moment. Then I realized, okay, this is UK, right? Okay, probably
Hmm.
this one, not this
It's a
one.
CIE paper, right?
Yes. So diameter have to estimate or to find volume. So I thought,
Uh-uh.
I think I have hold a football before. It's roughly the size of a ruler. No, 30 cm ruler. So okay, maybe I said 25 cm
This is the size of a
as a
human head.
diameter. Sounds like human head, I guess. You hold your head lah. You see roughly how long, how take a ruler put on your head.
Okay.
So I guess 25 is okay. I don't know.
Mm-hmm.
Let's try this out. So volume 4/3 pi r cube
Okay.
So 4/3 pi change to cm cube or no need. Okay, 25 cm cube. What is this value? 4/3 pi 25. It's about 65449 cm cube. Can this one? Do you
Uh,
agree?
I agree if your estimate for this is the radius.
Radius so big, whoa.
You put radius
25?
25.
Oh, yeah, GG.
But never mind, we got answer.
Radius can also. Wow, then the ball must be very big.
Yeah, but I guess
Okay lah.
what we care about if you listen to our previous video is the order, not the exact value. So if you estimate anything along the lines of 15, 20, 25 cm radius, should be okay.
So
Again,
radius will be smaller, no? Yeah, up
yeah,
to you lah.
estimate
I think it's this one.
the order because this one is 10 to the power of 4 and this one is also 10 to the power of 4. Okay.
Next.
Next. Bonus question. What is not a SI based unit? This one I like to quote my school teacher last time. You know, you know, you don't know, you don't know. Lor. What's the answer is what?
Yeah, I thought you should know. SI base unit. Okay lah, done.
Okay, next. This one also the same category. Two quantities are both vectors. You displacement is vector, distance is scalar, force is vector, momentum is vector, torque is vector, time is scalar, weight is vector, pressure is scalar. So B bonus. B for bonus.
Can lah.
Yeah. So
This
just a
one, you have to
reminder.
know lah.
Vector have direction and magnitude. So you just ask yourself which of the physical quantities direction means something. Okay, I'm going to adjust the question now to question 4. A calibration
Question
curve.
4.
Ah,
Wow, this one look like past year, miss.
really?
I feel
From
like,
what year?
yes, I got right down.
Oh, oh.
ON15 P11 Q4. Where's my 4?
Oh, so you're
4.
saying that Cambridge use back their own question one?
Yeah, lor, very interesting.
Do they
I
do that a
discussed in
lot?
class some more leh, this one. I
Oh,
remember because I discussed it in class. Student
okay.
asked me.
Oh,
But never mind.
okay. So what is this question about?
True reading versus what is shown on the meter, I think. Let
Okay.
us see. So
So,
here you have two
mm-hmm.
axes or current down there. I guess that's the true current, actual current in the circuit. Then up there is the reading, what you see on the ammeter or digital. Is this a digital one? Oh, I don't know. Whatever lah, the number shown there.
Okay.
So that is here. So two readings taken on the meter, different times. 0.13 MA and 0.47. So this one is the reading so I think is the one that is shown on the screen. So you draw dotted line there, you see. So the dotted line is drawn. What is the change in current? How much did the current really increase between the two readings? So it's talking about the true actual reading. So you have to read the change down there. How to read? I read
We take
Okay.
the reading here, which is 0.47, and the other one, which is 0.13. Carefully extrapolate downwards with a ruler, hopefully. And then we'll get here 0.14, which is the real reading instead of 0.13, and 0.44. It's the real reading instead of 0.47. So what's the actual reading?
Okay. Then calculate lor, change in reading.
So 0.3.
0.3?
0.3.
Okay.
Pretty straightforward. Circle. Okay, let me pen
Thing
and
looks
adjust.
correct.
So a student measures the length L and period T of the oscillation of a simple pendulum. He then uses the equation shown to calculate the acceleration of free fall G. So he measures the length and the period law. What is the percentage uncertainty in his calculated value of G? I think the first step I normally tell students is to please rearrange the equation. If you are like, should I power half, what to do? You rearrange the equation, make G the subject of your equation, can or not? Like for example, this is what Miss Ellie is doing now. You square both sides, okay? You square both sides, you bring the 2 pi over, square both sides, and at the end of the day you get
G.
G. The G is gone. GG. Isn't it G?
GG.
Isn't
What
this
am I doing?
G? Isn't this G? This is L. Okay. So to find the uncertainty in G over G, we will take the uncertainty in T over T, but times 2 or not, because of the square.
T got square. Last times 2.
And because the uncertainty is a compounded effect, so we are using the identities. So when you write like this, it's very clear. You will use T and L. T is square, L is power 1. If you look like this, then you confusion. Need to half. Where is the half? So I have seen candidates written like this before. Uncertainty in T over T is equal to half uncertainty in G over G plus half, because power half both uncertainty in L over L. Correct or not? You won't get the same answer.
Doesn't look quite right.
Yeah, you won't get the same answer because of the half at the delta L. Right? So yeah, this is our percentage uncertainty in G. We can substitute the delta T 0.05 over 1.9 times 2 plus 0.2 over 87.5. So if you do your calculation properly, it should be 5.49%, which is about 5.5. Okay? So yeah, don't go do some weird thing lah. You rearrange the equation. This one is just like, I don't know what is happening. I will draw a bunch of question marks here.
Yeah lah.
You laugh, I see this before. Miss, I lazy to rearrange.
Aya, don't lah. Rearrange better.
Yes. So please rearrange. Especially for your paper 5, if you're watching this and about to start your A2 journey. Okay, question 6. You're given a graph. An object is moving on a straight line. The graph shows the variation with time t of the velocity v of the object. What is the displacement of the object from point x? So at t equal to 0, because t equal to 0 is when the object is at point x, to t is equal to 0.8. So we're going to stop here. I guess we are looking for, how do we find displacement from a VT graph already, miss?
Displacement is area under VT graph, or area between the graph and the time axis, more like.
So this area here would be the displacement.
Also got one more at the left side, small one.
Oh, okay. Why is it one above and one below the time axis? Is it because
you mean got change in direction, I think.
Oh yes, because the V changed from positive to negative. Negative to positive.
So maybe it could be something like this. Maybe the ball goes up, then it starts to come down. Why my line so chacha? Come down. Then like that, then up there it will stop moving.
Oh, so this means here to here is S1, right? And
yes.
then
So the first part.
Here to here is S2, the second area. So
we can find area separately, though.
Oh, so you find it separately because we have to subtract, right?
Yes,
After you
yes.
reassign. Okay. So you find S1, I find S2 lah.
Okay, so S1 will be 1.8 meters, which means you will go up by 1.8 meters. Okay,
And this one is
so that will be this
0.2
one.
meter. So
So at the
S
end of the day, what are they asking for?
here to here.
Oh, so you minus lor.
Miss your
End of
label
the
a bit
day.
wrong.
Where's my label?
You look for S2, I look for S1. It's been a long
Okay,
year, guys.
terbalik.
It's been a long
Ay,
year.
terbalik. S2.
It's been a long year.
Okay, terbalik the label.
Okay. I rub, you right. So I think at
Okay.
the end of the day, we are looking for S2 minus S1, or the difference, which is 1.8 minus 0.2, which will give us 1.6 meter.
I
Hey,
agree.
okay, 7. What do you think about question 7, Miss?
I think this one is very
Deceptive.
gives you a headache the first time you look at it.
Oh, okay, let's read first. Whoa. Zoom in too much. Let's give us let's give us another headache.
Object accelerate now uniformly from rest to speed v, then it move at a constant speed for some time, 8 seconds. And then part 3, decelerate uniformly to rest. Wow, also got 3 parts of the journey already. Total time, 12 seconds. Total distance, 60 meters.
Hmm.
3 parts or how? Draw graph can?
Draw graph, please, because my brain cannot brain 3 different things.
Okay. Draw graph time.
Yep.
T, V.
Yeah, we're going to draw a VT graph because the information given is predominantly V and T. So the object will start from rest. So it starts from the origin. It accelerates to the constant speed V. And then it maintains at that constant speed. And then decelerate to rest. Okay.
Okay
So
lah.
as we wait for this one to sync, the red button is here.
Anyway.
I want you to think about what do you think that the acceleration and the deceleration have the same magnitude? So you can now see
They
the
didn't
two
say.
lines.
Oh.
We just want to accelerate to V, so this one is V, right? So you will accelerate from rest until speed V, and then this will maintain this speed for 8 seconds. Miss, can I assume this time is the same time?
Cannot lah. We don't know if they are same acceleration or not. Cannot.
Aiyo.
Just give it a
Okay,
name lah. Pick a name.
okay. I give a name. I will call this T1. I will call this T2.
At the end of the day, it's 12 seconds lah. So
Oh,
that's all we need to know lah.
correct. This is 12. Oh, first equation I want to write 12 is equal to 8 plus T1 plus T2. Aiyo, two unknown cannot solve lah, but at least I know T1 plus T2. Although they are not the same, it is 4 seconds.
We need another equation, miss.
We didn't use 60.
Okay, 60 total distance travel. So maybe the whole area under the curve should be 60 lor. So we have to come up with a triangle, a rectangle, another triangle area, all add together should
So
equal to 60.
half VT1 plus 8V plus half VT2 is 60. I am going to multiply everything by 2 and factorize my V.
Okay.
So this is T1. If I multiply everything by 2, the half goes away. 8 becomes 16. Multiply this one by 2. This will be equal to T2 because the half goes away. Multiply this one by 2. This is 120. I know what is T1 plus T2. T1 plus T2 is 4.
Given to us already. Oh,
So
we found
V
it.
will be equal to 4 plus 16 is equal to 120. So V is 120 divided by 20, which is 6, right?
6 meter per second. Correct.
Yes.
Yay.
Yay. So your ability to do simultaneous equation and suss out how to eliminate the constant, I mean the unknowns are tested here. So this is a little bit more challenging than usual. But everything else in this page is okay. 1 to 6 is okay. Just this one. Right, miss?
Quite new also. Never come up before this style of question of VT.
Ah. Is it?
Original question, very nice. Spray
Oh.
pen come out of the box, oh.
Ah. I like your sound effect. Hey, which other
Then you
physics
spray.
channel got sound effect live one?
I don't know. It's yeah, never mind. Anyway, so the thing come out got certain speed, 2.5 meter per second,
Okay.
400 holes. Wow.
Hmm. Okay.
With a certain area. Okay, that means it's like a whole bunch of gas coming out. I guess we could calculate something with that.
Hmm.
Density of paint. Oh, why they give density? Got area, got density.
What is the horizontal force required to hold the device stationary as it ejects the paint? Why do we need a force to... Is the device going anywhere?
Mm,
What what
not
what
exactly leh.
what conservation are we talking about?
Momentum.
Momentum. Ah. It's like you
Momentum.
shoot the paint out, so the what do you want to call this? Or the box exerts a force on the paint to push it forward. The paint will exert a force on the box to push it backwards.
Oh, okay, can. You imagine you sneeze that time, achoo, and then your head go backwards, but the gas go forward. Your coronavirus all go forward.
Bless us all. Bless us all. So anyway,
Okay.
we can find force using the change in momentum then. Because obviously the paint will have a change in momentum.
Mm,
So from Newton's third law, the force on the box to hold the box steady will be equal to the force on the paint, which will be equal to the change in momentum of the paint per unit time.
correct.
The
Miss, they
paint.
got give us time meh?
Use my favorite number lah. Let time be 1 second.
Okay.
Because what I will do now is momentum is equal to mv. So the velocity is not changing. So I will have change in mass per unit time. I don't have the mass. That's why they gave us the density.
Wow,
So
density.
mass per unit volume. Now here we need to be very careful. There are two V's. You don't accidentally go and square them or cancel them. Then I clap for you.
Okay. Noted. Noted.
I'll clap for the person because it happened to me before. So anyway, this one you can put the change. So is the volume changing or the density changing?
I think density is constant.
Yeah, lor, density is constant. So I will take out the density. You have the speed of the paint, density of the
Mm,
paint, change in volume of the paint per unit time.
mm.
So I guess to move forward here, we need to find out in 1 second, because that's the easiest way, in a unit time, which is 1 second, how much paint comes out of the hole. What's the volume of the paint? So you can assume it looks like a cylinder lah. Like a this one reminds me of a pasta machine. You want to press and the
You
pasta come
squeeze
out.
out.
But
Or like our poop, when we go toilet and poop, we push the poop out. Also same thing lah.
not out of 400 holes though.
Okay.
Very traumatized now.
No. Okay, never mind. Okay.
But miss, do we have the length of this cylinder looking thing?
Not exactly the length, but we do know the speed, 2.5 meter per second.
So since we
That's
let
what we do
time
know.
be 1 second, then in 1 second, the column, the height of this cylinder would be 2.5 meter.
Mm.
So then your change in volume will be 2.5 times A. I mean, A is this one. And you have how many holes? Because this is for one hole, right?
400.
400 holes. So we can substitute now. And now hence,
Mm.
your force on your paint will be the speed, the density, Change in volume 2.5 times 400 times A. Miss need to convert.
Convert, of course, millimeter square convert to. I guess it's good. It's good to convert everything to meters because newtons, meters, density, kilogram per meter cube. So convert lah. So when you convert everything, make sure you press calculator correctly. You should get 0.9 Newton. End of the day.
Okay. So I'm just going to continue the substitution, I guess. This one is 2.5. This is 900. If you want, you can press your calculator for this one first, just to get it out of the way. 2.5 times 400 times 0.4. Oh, and now I feel like a dum-dum because it's still 400.
Never mind lah. It's okay.
So you press calculator, then you notice that why did I press calculator? Have that happened to you before, Miss Annie?
Yes. Why do I press calculator? I don't need to do this.
Sometimes I
It's okay.
invigilate. I see students go and press things like 8 divided by 1.
You know, sometimes you're so tired, you're not sure about your brain. So just press lah, okay lah. You trust the calculator more than you trust your brain. That's okay. Yeah.
0.9 Newton. Okay.
Yes. There's another method which I guess can also add on to this.
Sure.
So
What's that
here
method?
you have to let t equals to 1 second, no? But then student will say, Miss, how you know to let t equals to 1? Why not other thing? Okay, never mind. There's another method here. Okay. So what you could do is, you know the volume is changing certain area times x.
Change in volume. So basically, we're substituting the change in volume with AX, which is the area and the length of the thingy. Okay.
Correct. Then x over t is velocity ma, so you just v lor.
Oh.
So rho AV squared. Done. Don't need to
Yay.
multiply so many things.
Okay, lor. So
That's another way lah.
yeah, but you can see this is also rho AV square. Because the V square, the V is here, the rho is here, the area is this one. And you press this one is your V. This is your area.
Yeah.
But if you do this, your area must be 400 times 0.4. Don't worry lah, this objective is very nice. If you've forgotten to multiply 400, you cannot get answer one.
It's okay. Never mind. Try again next time. If you ever see something like this.
Yeah, so multiply by 400. Okay, next, question 9.
Party balloon.
When my student came out from their exam, everyone asked me this question. But this was a drag force question that we rightly predicted will come out, right?
Yes. We give them air bubble lah. What balloon lah? I don't know.
Okay.
Okay. Party balloon, hold high up. Let go. What happened to the thing? The motion. So many statements.
So decelerate continuously. How would you do this?
Actually, you know this one, the statement one. Now I always tell people, you don't straight away go and read the statement. You think first what is the concept here. Unless you go there to the statements, A, B, C, D, you get super confused because they are designed to confuse you.
Yeah. Okay. I think what will decide the motion would be the resultant forces acting on the balloon, right? So we got weight law. The weight so tiny and cute.
It's air, man. Balloon where got heavy, so time draw small arrow lor.
Okay, so when you first so this from the moment of release, here is the moment of release. Moment of release. Let's say I call this T1 lah. So this is T1. So until it hits the floor, so to decide, we need to think about the net force. So at this point, there is no other forces but weight. But as it's falling, of course, there will be weight, and there will also be some air resistance or drag force. So if the ball
fall faster, right?
Yeah lah, so the ball is not going to decelerate, guys. If the ball is, you release the ball already not moving, and then it decelerates. I don't know what is happening to the ball. Okay, ball falls at constant speed and then decelerate. Wow, this one very scary.
Suddenly constant, suddenly it decelerate. Got magic.
Yeah, suddenly something that you cannot see is slowing it down, but it's not air resistance.
It's ghost.
Wrong. Fall at constant speed. Possible or not? You look at the force diagram. Starting got a little bit of force, so cannot be constant speed. So it will
I mean,
accelerate. Yes.
but then wouldn't it straight away go into terminal velocity, miss? Like you see, let go suddenly, terminal
You
velocity,
need a teeny bit of velocity to provide the drag force. If you don't move, there's no
Okay.
drag force.
Okay.
So maybe this one is for this balloon, and maybe if you, let's say, you don't look at something that have that many drag force, let's say a metal sphere, maybe the graph will look like this. No, maybe this one is for a basketball of equal size.
Mm.
Maybe this one is a balloon. So you can see it will fall at a lower terminal velocity. My graph is not nice, but this one should be something like this lah. Okay.
So I guess D is the best choice then. Okay.
Yes, D is the best
D it is.
choice. Okay.
So you accelerate your 9.81, then you
Mm.
decrease to 0. Okay, then constant speed now.
Yeah, and you decrease to
Okay.
zero fairly quickly because it's a balloon. That's why you got the confusion and have the compulsion to choose C. Because maybe the
Because we
time
played with
taken,
balloon before, ma.
yeah, and maybe the time taken to reach constant speed is pretty short lah. So you didn't perceive it as well. Oh God, what did I do?
Oh, it's back. Okay.
Okay, question
Next,
10.
collision.
Mm.
This one is two balls collide, stick together.
Piang.
That sounds like an inelastic imperfectly inelastic collision. Stick together after that,
Imperfectly
what
elastic.
happened?
Okay. They move together lor.
Mm. So
So
before, after, okay lah.
be after they dun, 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 6M. They move with V.
Yeah, why they join together? Draw lah, two thing.
Hiya.
Okay lah, never mind.
Okay lah, okay. Nah.
Nah, nah.
1M, 5M. And this one is V. Okay.
So you need to do your calculation lah. Okay, you just see this. This one actually quite straightforward lah.
You
No, I
talk
don't think
lah,
there's
I write
any
lah.
trick. Okay, so this one, okay lah. So you need to use your conservation of momentum. Total momentum before equals to total momentum after. So that will be 5 mu plus 5 mu. That's the total momentum. The small ball, big ball equals to total momentum after. So 6 mv. Because they move together, so they should have the same speed. So now we need to find the V. So you rearrange everything so that V equals to 10 over 6U.
So easy. I like. No ratio of
But,
kinetic energy, nothing.
but some student, they say, Miss, 10 over 6 is the same thing as 5 over 3, or don't have answer 5 over 3, or Miss, this question. Then how? Some student, they say, they press calculator, then they see 5 over 3. That means there's no 5 over 3. Hello, 5 over 3 and 10 over 6 is the same thing. Anyway, question 11 is actually a past year that appeared before.
Oh, air
Very pretty
bubble.
one.
Is this drag
This one
force?
also kind of drag force. We also asked this in the model paper. Air bubble going up in the thing one, all those things.
Mm-hmm. So I think just now you draw the balloon, the W was very short. Is this W also very short?
Probably. Air bubble, where got so big? Cannot be
So
lah.
C and D is wrong now.
A and B, how to decide, miss? What's the difference?
Constant speed, I think. So net force must be 0.
Net force 0 means all the downward force should equal to the topward force.
Yeah.
Oh, this diagram is drawn to scale.
Make your best guess, lor, even if it's drawn to scale.
I think A looks better because the upthrust is so big. So your W plus V should probably be roughly that size as well.
This one is too small or too short.
Okay lah.
Okay, pretty
Can.
straightforward. 12. Ooh, a couple.
Torque.
You want a 9 Newton meter torque. So I will use torque is equal to one of the couple times perpendicular distance. So this is 4.5 Newton meter.
Wrong liao leh.
This one is 45 times 0.1. So this is 4.5 Newton meter. Hang on.
Calculate.
Then this one here would be 9 times 1. So this is 9, because 100 cm, 1 meter. 9 Newton meter. Got 2 9 Newton meter. Which one?
Check direction.
Clockwise.
Oh. So our
Ah.
friend, clockwise.
And the other one is counterclockwise.
Big. Draw big for you to see.
Okay. All right.
Be
So
careful lah.
yeah. But they are helpful. They are nice because they put B first. So people would normally tend to test B first, then they will circle B.
Good lah.
If they
Can
change
lah.
option B and D, maybe another 10 to 20% of students will answer wrongly.
Aiyo.
Equilibrium question, shelf PQ.
Looks like the moment type of question, no? But then it's not. Here you have a shelf attached to a vertical wall, support a book. Blah, 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 blah. They tell you all the weight, WS, WB, all pointing down, angle theta. Shelf is in equilibrium. So that is the part where it's important. What does equilibrium mean? Well, you can say net force 0, net torque or net moment is 0. So which one do you say? What are they asking? What are the magnitudes of the horizontal and vertical component of the force of the wall on the shelf? Well, how to draw? Where is this force? Okay.
At P. Right?
Force of wall on the shelf. Yes, correct.
At P.
So if the shelf is not flying, it's not twisting, it's not turning, it's not sinking into the wall.
Miss, I would like the shelf to stay in place.
Imagine your bookshelf is just
rotating.
Doing what? You will say you got ghost here. Okay, never mind. So it looks like you have to have an upward force on the shelf at P because all the weight, everything all downwards. So
Miss,
you
what about this
gotta have
F?
something pointing up.
What to do with the F?
Yeah, we don't know. The F has both horizontal and vertical.
Is this the F acting on the shelf?
It looks like it.
So
usually they don't draw the arrow lah, but this time they did. So
yeah.
I guess you assume it's pointing on the shelf.
Yeah, and I think
pushing up.
A common error for people is that they resolve at the wrong position. Maybe they resolve here and then they think that it doesn't act on the shelf. Or they could resolve here. Some weird thing will be happening here and I don't know what is happening because this one is pointing up. How can this point down? So a good way to overcome your lack of spatial coordination, when I mean you, I mean me as well, because that happened to me so many times, is to actually transfer the arrow. Don't care anyhow, all the forces must act pointing out away from the object in question. So the system that you're analyzing is the shelf. Everything else I don't care. I just care about the forces acting on the shelf. Yeah, so then we can resolve this one, right?
Can. There's a horizontal, there's a vertical.
Okay, so we're going to resolve this one. This will be F. Theta we transfer. This is theta, right?
Yes, correct.
So this is F sine theta, opposite the angle. This is F cos theta, beside the angle. So what were you saying about the force at P again?
You know, the horizontal force should cancel out. So if the red color one already pointing to the right, there should be a horizontal force at P pointing to the left, cancel out ma. Or the left force cancel out the right force.
This is
so
a contact force. Maybe there's some screw here, look a bit odd and different, but maybe there's a screw here that is helping hold the shelf in place.
Okay, so we can already find an answer.
Oh, really?
So,
okay,
horizontal component the green color one that you just
so
wrote
left
is
must
the
be equal to
component.
Right.
Yes.
So
F
this
cos theta
must be equal to F cos theta. Okay, this one and this one is wrong. Hiya.
Then vertical
can I say that if F cos theta is in horizontal, F cos theta cannot also be in vertical?
How do you be horizontal and vertical at the same time? You're perpendicular.
Magic, Miss, I am listening to physics lecture while doing further maths homework at the same time.
No, cannot. Horizontal is different from vertical. They are separate. They do not. They are okay. Never mind. They're separate lah. Okay, but confusion. Why got cos and cos cannot be lah?
So by elimination, we would know that the answer is B lah. But if you want to satisfy yourself, you can go back and balance off the vertical forces as well. The
Mm-hmm.
upward force will be equal to the downward force. So there could be a force here. Maybe this is Fp lah. Fp in the vertical direction. So this is y and this is Fpx. So Fpy plus F sine theta will be equal to Ws plus Wb. So Fpy will be equal to Ws plus Wb minus F sine theta.
Yeah, looks good.
A glider is descending at constant speed at an angle of 15 degrees to the horizontal. The diagram shows the direction of lift, air resistance R, and weight W acting on the glider. Which vector triangle could represent the forces acting on the glider? Are there any... Oh, constant speed. So that tells us that it's in equilibrium, right?
Mm-hmm.
So equilibrium, we should see a cyclic triangle, but miss, they're all cyclic triangles. Do you like to make
You
my
check
life
the
difficult?
check the vectors lor.
Okay lor. I think the easiest one to check is W. W must be directly pointing downwards, but everybody also got a vector pointing downwards.
Okay. Then R leh. Maybe we see R. It should be up and to the right a bit, right?
Yes. So up and to the left a bit for B can throw away.
Okay.
Up and to the right a lot in C can throw away.
Okay.
In fact, A is also up and to the right quite a lot, so also can throw away. So
But maybe it's correct leh. Maybe we keep here. We check L first, then we know for sure.
So
lor.
basically, the wrong one I highlight lah. This is wrong. This is wrong.
Then the other one to check is L only lor. Up and to the left a bit.
This
Wow,
is
that one.
not up to and to the left or this one.
Wrong now lor. So many.
So the answer would be
D. Looks like the best.
Mm.
Although the vectors are not to scale that they draw, they try to throw us off, but you can look at the direction. It should help.
The direction is more important than actual scale itself.
Mm-hmm. Okay, next.
Wow, this diagram never see before. A solid
New
cylinder
question.
of this density rho C cylinder, cross-sectional area A, length X is submerged in the liquid of density rho L. So the liquid outside here is rho L. Upper face of the cylinder at a depth H below the surface. Acceleration of free fall is G. Which expression gives the magnitude of the upthrust acting on the cylinder?
Upthrust means there's an equation for upthrust, huh? That would be rho Vg.
Yeah, but I can also use the upthrust is equal to... I mean, we can use rho Vg, but I was thinking of using the change in pressure between the top and the bottom times the area.
Can also. I mean, that's basically rho Vg.
Yeah,
they're all the same thing lah. They derive from each other one. Yeah, can also lah.
So this H is the difference in height. So this will be X rho G times A, the area. But so there are two possibilities. Is there a two possibility? I guess
rho G AX.
Rho.
Oh, this density of liquid.
G.
Rho L. You must say rho L.
How do we know whether it's rho L or rho C?
Because the pressure that you use is due to the liquid now. The height of liquid pressing down on you.
Pressure difference of liquid. Okay, so they are trying to throw you off by giving you double density lah. But you are smarter than that, right? So the answer is D. Hopefully you are.
Now this question 16 look damn familiar. Because I think it come up before in some of the exam, sem 1 or some tests. Remember
A
this.
ball drop on the horizontal surface and boing, 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 boing. But it rebounces elastically. What happens to the kinetic energy of the ball during a very short time? Means I know, elastic kinetic energy no change.
Why no change there? Doesn't it stop
Elastic
moving?
ma. But elastic leh.
But okay, wait. Let's draw it out. Let's try to draw it out. Ball come down. Ball hit the table. I guess stay there for a moment. Go up and it's away. Elastic just means before and after have same energy ma, same speed
Mm-hmm.
v and v. But wouldn't it stop moving for a moment?
It stopped moving because the kinetic energy converts to elastic potential energy, right? Due to the deformation of the ball. So the kinetic energy is going to
Mm.
decrease to zero and it's going to return to original value.
Yes.
Am I thinking on the right track?
Yes, sounds correct. But Miss they never say it's a rubber ball. How we know? I don't know. Yeah, things have to kind of deform a little bit to bounce, right?
Yeah. There's no such thing as a perfectly hard surface.
It always has this point thing.
Yeah, no matter how hard you think that thing is, it is still deforming. You just cannot perceive it because we are humans. We operate at a certain scale.
Yes.
Okay, 17. Also familiar, this one. Also past year.
And we haven't chose answer yet, B. Okay, never mind. Continue. Familiar?
Okay. Familiar?
Yes. I found it already.
Yes, which year?
MJ16 P11
Okay,
Q16.
so we are looking for efficiency. So we are going to take the useful useful work done, which is due to the expansion of the gas. So work done by gas. Why does the gas have energy to do work leh? Because heat is added or thermal energy is given.
Mm.
Mm.
That's the input, no?
If you happen to learn this topic before you sit for your AS, because it's the early chapters of your A2, that will actually help you write this with a bit more conviction. Lah. But if not, then never mind, can still do what? Work done by the gas will be pressure times volume difference, which is
Mm.
VF
VF.
minus VO. Then the thermal energy, the input is Q.
Got
Yes.
answer already, or miss?
Oh, you already. Oh, okay. The answer is C. We will use this equation a lot in A2 in the
Good
gas
to
chapter.
know.
Good to
Good to
know.
know.
Miss, why they ask this here? That one I don't know.
I don't know.
Never
Yeah,
mind.
A2 stuff.
I just like to make a guest appearance.
Guest appearance. Hmm.
I saw what you did there. Okay, 18. An object. Oi, past year also.
Also,
Hi.
I found no.
I think they reach this point, they're very tired now, so they just keep taking from random past year and copying. I don't know.
Okay, never
We
mind.
sus. We set one past year, we set one model paper one also very tired already. Okay, so you have an object 0.3 kg. And they keep throwing the ball, bouncing the ball, throwing the ball at each other. 0.3 kg thrown vertically upwards from the ground with the initial velocity of 8 meters per second, reaches a maximum height of 1.9 meters. Okay, how much work is done against air resistance as the object rises to the maximum height?
Energy conservation? Can use
Can we
Okay.
can say that the change in KE, the loss in kinetic energy, if there's no friction, it will be directly equal to the change in GPE. But there is
Air
friction.
resistance.
So work done against friction. We are looking for this one, work done against air resistance or friction. So this one we can put half mv square. This one is mg change in height. This one is work done against friction. No. So substitute lah. What is the mass? 0.3. What is the speed? 8 square. 0.3. 9.81. The change in height, it has risen to 1.9 plus WF. So you can find the... Okay, miss. Let's see what the setter is thinking. Let's calculate this one
This
and
one's supposed to
calculate
be
this one.
4.4 joules. 4 joules.
This
Oh,
is
that
4.
side. Oh, you want to think of that side. Okay.
What is this? I think this is 9.6. I think this is 5.6. And this is WF. Do you
Yes.
guys see the trap here?
They throw everything inside there for you to see.
There's 9.6, there's 5.6, there's 5.6 plus 9.6, which is 15.
Hmm.
But
Tricky,
it's
tricky.
no lah, sajala. They are just testing for people who don't know what to do. Because normally students memorize the equation. But sometimes they don't know whether the work done against the friction should put on the left, should put on the right. They don't know where to put because they're not thinking about conservation. When this ball is traveling up, it loses KE. So it's the loss in KE will be equal to the gain in GPE. And who is taking away some of that gains? Friction. Without friction, you
The air
can travel
become hot,
higher.
lor, or
Your hair
something
become
like that.
hot. Okay, so this one will be 4 joule lah. Okay, water pump.
Okay.
This one not past year.
No, this one new.
Mm.
Very new.
Work done over time.
Work done will be MGH, change in gravitational potential energy because the water go up 80 meters in 1 hour. Wow.
So this is a
A lot
hint
of.
lah. A hint. Mg
Hmm.
change in height over T. Okay. 27 times 10 to the power of 3. 9.81. The change in height is 80 over... Can I put 1 ah? Yeah, cannot ah. The watt here.
Got must in second, don't put hour.
Okay.
Convert hour to second. Okay, multiply everything, you should get about 5,000 over almost 6,000 kilowatt. Very nice.
Okay, very
Yeah,
nice.
okay.
Pretty straightforward. So whenever you see power, just think of what is the energy changing and how long did it take for that energy to change. The question should give you enough leeway. All right, 2 more before we get to waves. Oh, this is what? Clone?
There is a
Clove?
partial very similar to this.
Or is it
But
the building one?
no. There's like one where there's 2 rods and something hanging from it. But
What?
you have to know to divide the force. Okay, anyway, let's look at the question.
Mm. You talk lah,
Platform
I write lah.
suspended 4 steel wires.
Mm.
Each wire got length lah. Okay, so
Mm.
all this when you read this, you should already straight away start labeling already. Young modulus E, diameter D. Then you think, oh, what formula to use? Okay. Wire obey Hooke's law. When a load 200 kg is placed on the platform, so this will be your related to your load F question mark. How far will the platform descend because of extension? So they're asking you what's the total extension. So you can already start thinking about the load, the force, but are we going to put the whole 200 kg there? Let's think about it. I don't know. What do you think, Miss?
They share the load. So when you are struggling, don't struggle alone. Go find some friends to struggle with you. Then your load can be mg divided by 4.
Can. Then the rest you plug in, no? Your
Length is 5
original
meter.
length, yeah. A
Uh,
or diameter pi d square over
over
4.
4. Can I just put 1.5?
Sure. Mm-hmm.
A bit running
And don't
out.
forget the Young's modulus.
Yes. Wait,
So if you press calculator correctly, I think the main trap is trying to remember to divide by 4. If you remember to do that, the rest should be okay. Plugging, calculating, you should get about
pi d
1.65 times 10 to the negative 3.
squared x. Correct,
So you
right?
rearrange to find x.
Everything
Correct.
okay, right? Okay.
Yes.
So x is 1.7 times 10 to the power of negative 3. Or 1.68 lah, right?
Somewhere there.
There's a trap here, miss.
Where's the trap, miss?
You see this negative 4?
Why so close one?
Because if you accidentally forgotten to multiply by 9.81, which is about 10, then this will be 10 to the negative 4.
Oh no.
Then you will choose A lor. Then you GG lor. That's all.
It's okay. It happens.
Sometimes I like to, when I do question, I like to see the traps. Then I'm like, ha, I didn't fall in it. Or crap, I fell in it. Okay, 21. Miss, tensile force 7 mega Newton is applied on a sample of steel. This causes the sample to extend by 5 mm in the direction of the force. Ooh. Okay. Sample obey Hooke's law. What is the work done? Can I use... Wait, Hooke's law. Can I use half Fx?
Can because his Hooke's law is pretty much like a spring. Like, Hooke springs. So half Fx or. But the force, should we use 7 meganewton or 14 meganewton?
7.
Miss, but then got left side also got 7, right side also got 7. Whoa.
You think of a spring lah. Let's say you take a classic spring, you hang this way, and then you got this 10 Newton. Yeah, I don't know lah. You hang a 10 Newton here. What force do you use to find the energy stored in this one? This work
I think you use
done
one
here.
side only, right?
Work done here, you take half Fx, and this F here you will put 10. Right? You know why? You could be thinking, but miss, this one only got one force. Lies, there are two forces.
The ceiling
force,
also will pull.
yes. If you look, if you only pull force in one direction, it will not deform. The entire spring will just accelerate. Just like if you only
Fly
pull
down
with
there.
7 meganewton, it will just go to the left. It's not going to go anywhere. Okay, so this one will be pull downwards. No, pull upwards. Then that we will have some extension. So when they say the sample extend by 5 mm in the direction of the force, can we draw the final... Okay, I rub this one so you got space. Can we draw the final shape?
Extended.
Ah,
I guess force is horizontal, so maybe a bit longer. Something like that.
actually, I'm wondering whether it will extend on both ends. No.
Probably will. Well, I could draw that way.
So
Because
if
it's the whole thing will extend, the whole thing get longer.
So if it extends by 5 mm, is it 5 mm on one side or 5 mm on two sides?
I guess it means the whole thing.
Okay.
They're not exactly clear here,
In the
but I
direction
guess
of the force. So
I would assume there's force on both sides, so you extend on both sides, no direction of the force.
so this is 2.5,
It's very
2.5.
strange. Probably.
5, 5. Let's pretend it's 5 first and see whether got answer or not.
Okay.
W is half Fx. So
Remember to convert millimeter to meters when you do your calculation. Because energy, joules, all these, you are using SI units, so make sure they're all in meters when you do your calculation.
okay. This one is 17.5, right? Kilojoule. Is that what we got?
Yep. If this assumption is correct, then it should be 17.5.
Means I actually think that this question is so unclear because then the answer will be C. But if I extend 5 mm to the left and right, then the answer will be D already, right?
Yeah, no? So it really, we don't know leh.
So
They didn't really say
we
extend
wait
by
for
5
this
mm.
one is a wait for examiner report question.
Yes.
It could be both of us think too much or I think too much because I just thought of it. When I was doing the question, I didn't think of it. Or it is indeed a trap. They expect this one to be 5 mm and this one is 5 mm.
Maybe we should circle both questions, both answers, if we think it is 5 and 5.
Then on exam we shade both lah.
No lah, cannot lah. But now we question mark so we put both lah.
Okay lah. So basically,
Pending.
Teacher also don't know liao.
Question is not exactly clear.
Yes.
So, but I will put my bet. If I had to choose this in exam, I'll probably choose C lah. But it seems too easy to do that though. Why is this question so easy? Very suspicious
Yes, because when you ask me that question of whether the force is in both direction and I drew this diagram, then I began to suss myself.
It's okay. We don't know. We'll see how.
See, it's normal. Even teachers suss themselves all the time, which is a physics thing.
Especially when questions seem too easy. Like, why is it so easy? Something wrong here.